Education Society, redefining excellence.
Hello everyone, my name is Mubarak Muhammad Momin. I am studying in Zeal Polytechnic Nare from Civil Department. We made a maths project with the help of our group member Ramzan Mullah, Pratham Bendekar, Vishal Gonte, Yogiraj Patole. The subject of this project prepare model using the different equation for population, and this guided by Naneshwar Padwal sir. Population growth. Population growth is a dynamic process that can be effectively described using differential equation. We consider here a few models of population growth proposed by economists and physicists. First, Malthusson growth model. The simplest model was proposed still in 1798 by the British scientist Thomas Robert Malthus. This model reflects exponential growth of population and can be described by differential equation, where A is the growth rate, Malthusson parameter. Solution of this equation is the exponential function, where NO is the initial population. The given simple model properly describes the initial phase of growth when population is far from its limits. However, the accuracy of the exponential models drops at a later stage due to saturation or other nonlinear effects. Second, logistic model. This kind of population models was proposed by French mathematician Pierre-François Verhulst in 1838. This model is also called the logistic model and is written in the form of different equation, where m is the maximum size of the population, and the right side of this equation can be presented as, where the first term is responsible for growth of population and the second term limits this growth due to lack of available resource or other reasons. Third, hyperbolic growth models. The models we considered above are useful in the analysis of demographic process on a scale of centuries. If considered population growth of several thousand years, it can be seen that the main explosive for growth from 2 to 7 billion people occurred on the past 50 years. This type of deficiency is similar to the hyperbolic curve. A simple hyperbolic growth model was suggested by several researchers, one Foster 1960, one Hoster 1975, and Shklovsky 1980 in the following form. As it follows from this model, the world population goes off to infinity as the year 2025 approaches. However, the real growth dynamics demonstrates that the so-called demographic transition follow after the explosive growth phase. This new state is characterized by declining fertility and mortality. Such a transition has already occurred in many developed countries. As a result of the demographic transition, the population growth crashes and may even fall. The global world population had just entered the phase of demographic transition in the beginning of 21st century. It turned out that such a complex population dynamics can be also well described using differential equation. A model of this type was recently developed by Russian physicist Sergei Kapitsa. Kapitsa proposed to describe the explosive growth using the following equation, where a certain approximation parameter, this differential equation has the exact solution as a function. The function describes the explosive population growth remarkably well at all the following values of the parameters. Besides that, the model curves and demographic transition pace when the population growth reaches saturation. According to this model, the global world population will reach about 12 billion in 2200 to 2300. Thank you.
Zeal Education Society, redefining excellence.